Okay, let's look at example 9C. Okay, same thing. The first thing that we should do is you have to do the factorizations. So at the bottom, okay, we can factorize out the x. So we will have x squared plus 1. Okay, we factor out the x. Okay, so we have the x. So once you have done with the factorization, the next thing that you should do is the decomposition. So we're going to do the decomposition. Okay, so we have x plus 3 and x squared plus 1. Alright, okay, in here, okay, we're going to split into two. This one is a different factors. This is a linear factor, so this x, and you have a quadratic, you have quadratic x squared plus 1. Okay, so when we have a linear at the bottom, so on the top will be constant. Okay, and this one is a quadratic. When you have a quadratic at the bottom, at the top you will have linear functions. Okay, so you will have bx plus c. This linear. Okay, this linear, and you will have constant at the top. Alright, okay, what's the next step? The next step is you have to multiply each of the items that you see here with some factors. Okay, so multiply each item with some factors. What is the factors we need to multiply? That is the one that is at the left, and we take directly the denominator become the factors. So we will take this one, so it's x, and this x squared plus 1. Okay, so we're going to multiply each item that you see here with this. Okay, so we're going to do it very fast. Okay, so you multiply this fraction with this. So basically this cancel, this also you cancel. The remaining of x plus 3 only. Okay, how about this fraction? So these fractions you're going to do multiply with this. So if you multiply, the over x will cancel with x here. So the remaining of a and x squared plus 1. So a x squared plus 1. Okay, and then this one will be the same. This one cannot cancel with others. Okay, so we have bx plus c. What we can cancel is the denominator, this over x squared plus 1. This one you can cancel with this because later this fraction will multiply with this. So if you multiply x squared plus 1, you can cancel out. So if you cancel out, the thing that remain there will be bx plus c and the x. Okay, cancel, we have x only. So that is our second line. So once you obtain the second line, so you're going to compare the left hand side and the right hand side. So let's look at the left and the right. Okay, so we're going to look at the highest power that you see. Okay, the highest power that you can see that is x squared. That is coming from the right hand side. But doesn't matter it's coming from the left or coming from the right. We need to start from the highest power. Okay, the highest power is x squared. So let's just look at the left hand side. So your left hand side, we do not have x squared. So when we do not have the x squared, means that you have a 0 x squared. You have 0 x squared, just write 0. For the right hand side, the x squared that you can see is ax squared. So you just have to write the a. Okay, how about here? So we have bx squared. So just write the b plus b. Okay, that is the first equation that you obtain from comparing. Okay, so for the comparison. Okay, so that go for x. So for the x, for the left hand side, we have x only. This is considered as 1x. So we just interested to know the coefficient. That is 1 here. Okay, 1x. Just write the 1. Okay, you don't have to write the x anymore. Just write the number 1. Okay, and then the right hand side. Here is the right hand side. Where is the x? The x is coming from here. You expand this. You have cx. We have cx. but we're only interested to know the value of the value in front of the x, that is c. So that is the second thing that we obtain from the comparison. Okay. Last, we will go for the constant. So for the constant, so left hand side, that is 3. For the right hand side, so right hand side, if you expand this, we have a. Okay, so we expand this, we have a, and that's all. That's all. Okay, so just the constant that is. Okay, so from here, we already have the information. The next information that we need is the value of b. So in order to get the value of b, you just have to sub this a into here. So sub a equal to 3 into number 1. So you have 0 equals to a is 3 plus b. So b here, that is minus 3. Okay, so now you already have the answer for the a, for the b, and for the c. So how are we going to do with this value? Okay, so we're going to sub it back to the equation that is here. I'm going to sub it back here. Okay, so let me rewrite the equation. Okay, let me rewrite this. We have x plus 3, x squared plus 1, okay, over, okay, equal, okay, a. My value of a, yes, that is 3. So I have 3 over x. So that is my value of a. Okay, plus bx. What is my b? My b, that is minus 3. So I have minus 3 x plus c. My value of c, that is 1. Alright, over the x squared plus 1. X squared plus 1. So basically what I did here is I'm doing the substitutions. I sub the value of b, I sub the value of c inside the general form. Okay, once I have obtained the proper decomposition, the result of decompositions, what I need is I need to substitute. Okay, so that is what I obtained just now. That is what I obtained just now. So what I have to do is I need to substitute this into here. Alright, okay, so continue the next line. So if you continue the next line, what you see is you will have integration of this 3 over x plus minus 3x plus 1 over v. Let me rewrite it. Okay, so we have minus 3x plus 1 divided by x squared plus 1. Yes. Alright, okay, so once we have written this line, so we no longer need this anymore. So I can erase this. Delete this. Okay, so okay, let's look at this. Okay, so now, okay, so let's just continue the integrations. Okay, this one you can split into 2 parts. Okay, so when you split into 2 parts, you can think of as this one as okay, you can think of as 3. And okay, 3 over x, right? You can extract out the 3, so you have 1 over x, okay? And with the dx. Okay, and another one that is, this one don't extract out the minus 3, right? Okay, just keep it that way. So we have minus 3 x plus 1 and x squared plus 1 dx. Alright, okay. So what I'm going to do here is this one you have the direct integrations. If you do the direct integration, so this one is basically give you 3 ln x. So this we have settled. Okay, so we need to settle this. Okay, so in order to settle this, is actually back to this already back to the previous basic that we learned. Okay, when we have when we have something set like this, that is a previous chapter, that is type 1. Okay, so you have to refer to type 1 how to do with this. Okay, but okay, let's see how to do this. Okay, so you have to split into two. Split into two. If you split into two, what happens is you will have one is for the minus 3 x. Okay, so one is for minus 3 x. Okay, and x squared plus 1 is dx. Okay, and then another one that is 1 over x squared plus 1 dx. Alright, so we split into two integration. Alright, we split into two. Instead of 1, we split into 2. Okay, let me copy this to the bottom. Okay, because I need a larger space. Okay, so copy the last line and this, right? Okay, so once you have split them to two different integrations, okay, now we're going to look at them separately. Okay, so we're going to look at them separately. And this, okay, you have to refer to your formula list. And this is, you're going to use the formula list that is the integration part, that is A7. Okay, so you're going to use the formula list that is A7. That is the integrations of f prime f is equal to ln f plus c. And again, this is, you're going to use the formula of A7. And this one, you're going to use the formula of the C1, the formula of C1. C1. Okay? So C1, that is integrations of the 1 over x squared plus a squared dx is equals to 1 over a tangent inverse x over a plus c. Alright, okay. So in order to use those formulas, you have to ensure they are in the form that you can use. Okay. So if you want to use the A7, you have to make sure that you have the proper f prime. If this is your f, okay, let us see. If this is your f, that is x squared plus 1. So what do I need? What do I need for my f prime? My f prime is supposed to be 2x. So I need to have 2x on the top, just so I can use this formula. Okay, but I do not have 2. Okay, what I have here is minus 3. So what I will do with this? Okay, so let us see how we're going to do this. Okay, the minus 3, we don't want it. Okay, take it out. Take it out. Just take it out. And if you take it out, you will have like this. You have minus 3. And we're remaining of x only, and over x squared plus 1 dx. And again, okay, this is your f. I need my f prime. I need my f prime at the top. Okay, so in order to have my f prime, I require to have the number 2. Okay, so I require to have the number 2. So we're going to do some magic here. So we're going to add the 2 here, add the 2 here. And in order to not changing the question, so you have to divide by 2. You cancel back, they are the same. They're the same, right? We did not change the question, but we do in that form just that we have the form of this is function f, and this is your f1, right? Then that is the exact form of the formula of A7. Okay, so the A7 says that your result should be equal to ln f. Alright. Okay, this one, okay, I will write it later. I will write it later. Okay, let's go to the next slide. So this is still 3/2. Plus minus is minus. So this one you integrate by using that formula of A7. This is give you ln x squared plus 1. Alright? Okay, how about this? Okay, so this is going to use the formula of the C1. The formula of C1 that it should be in terms of square. So what you have here is you have x squared plus 1. The 1 here that is actually 1 squared. Alright, okay. Now we're going to plug in the formula of C7. Okay, the formula of C7 says that you should have 1 over A. What is your A here? Your A here now is 1. Okay, so we're going to have the next side that is 1 over 1, tangent inverse, and x over 1. There's your A. It's up here. Right? Okay. So don't forget to write the part C and simplify your answer. Okay, simplify your answer. Okay, and this is tangent inverse. Let's see. So yes. Okay, so that is the answer for the C. Okay.